So we are going to identify quadratic functions today, and a quadratic function is just the graph of the equation y equals ax squared plus bx plus c. So when we graph those things, what you're going to see is a smooth and symmetric U-shaped graph, and these happen to be called parabolas. And then you've got a vertex of the parabola, and that's what we consider to be the turning point. So that's where the graph goes from going down to going up, or going up to going down. This highest point, which would be right here, or this lowest point, that's your turning point, and that's what we call the vertex. If you're asked to graph a function using a table of values, you should not need a graphing calculator for this. You should be able to do it on your own. But everywhere they give you an x value, you actually plug that in, and then you make your graph. So if I wanted to take -2 as my x, and I wanted to square -2, what would come out would be a 4. If I wanted to square -1, what comes out to be a 1. If I were to square 0, what comes out is a 0. And then if I square 1, what comes out is 1, and then when I square 2, what comes out is 4. Notice how you have a turning point in the center of your graph. That's where your vertex is going to be because the points on either side of it totally match up. What I mean by that is on the top and the bottom of 0, you've got a 1 and a 1. And on the second two parts, the top and the bottom, you've got a 4 to a 4. So we're symmetric on either side of the vertex. When we graph this thing, -2 to 4, I'm not oriented very well, as you can see. -1, 1, 0, 0, 1, 1, 2, 4. And then we have this U-shaped graph. Okay, so that's the first parabola. Again, I'm not oriented so well, so yours look much better than mine. If we take now a look at this next one where we're looking for y equals the negative of x squared, you're going to get different values because you're actually going to do the negative of -2 squared. What you have to do is do the exponent first, which comes out to be a 4, and then carry over your negative. So negative of -2x of -2 squared becomes -4. The negative of a -1 squared becomes a -1. The negative of a 0 squared becomes 0. The negative of a 1 squared becomes -1. And the negative of 2 squared becomes -4. And again, that should make sense. Your graph should be symmetric about the vertex. The vertex is the turning point. It's going to be that point in the middle. And the points on the other side of it on the y's have to match up. So to graph this one, -2 to -4 is down here. -1 to -1, 0 to 0, 1 to -1, 2 to -4. Notice how this graph has kind of changed its position. It opens down as opposed to opening up. And there's a reason for that. Let's take a look at the next thing. Here's what it talks about the reason. Notice how one graph opens up and the other graph opens down. Why does this happen? So the reason being is if we go back to these particular graphs, notice the coefficient in front of the x squared term. This coefficient is a positive 1x squared. This coefficient is a negative 1x squared. Whenever your x squared term is negative, that's when your parabola is going to open down. If ever the a squared term is positive, the parabola opens up. Remember, a is the thing that's attached to the x squared term. So let's go back and fill in these blanks. So a parabola opens upward when another way to write greater than 1 is when a is positive is a is greater than 0. This basically means that a is a positive value. If this is the case, then the parabola, the vertex of the parabola happens to be the minimum point. It's the lowest point. I didn't spell that right. Let me fix this. Minimum. If the parabola opens downward, then the a term is going to be less than 0, or the a term is negative. And in this case, the parabola is going to be a maximum. The vertex of the parabola. So I'm just going to go back to this other graph for 1 second. The a term happens to be a positive value. The graph opens up. The vertex happens to be the lowest point possible. The a term attached to the x squared is negative. The parabola opened down, and the highest point here, the vertex, happens to be a max. Okay, the next thing that they're going to ask you to do is to identify the vertex of the parabola and determine whether it's a max or a min. Well, the vertex in this case is going to be the highest point, the turning point. Here's the vertex. If we take a look at the grid that we have below, the vertex is on the axis, it's going to be over 1, up 1, 2, 3, 4, 5. So the vertex is 1, 5. That's the turning point, happens to be a maximum. On this one, the vertex is going to be a minimum. It's the lowest point. And the actual coordinates of the vertex would be, I've got to go over to 2 on the left and then down, in this case 5. So the vertex here is -2, -5. That should be pretty easy to give in a graph. The next thing we have to determine is domain and range. Don't forget that the domain is always going to be the set of x values. The range is the set of y values. So when we look at this graph, and it's kind of hard to tell here because we don't have the table of values to see, but the x values, I could go on forever and ever on my x values and always get an answer when I plug something into a quadratic equation. So what happens here is the domain, this is for any quadratic, but the domain is always going to be x equals real numbers. Not reals number, but real numbers. And that's always going to be what the domain is. I can choose any value for x, plug it in, do the math, and get a value for y. But it's the y value, the range, that's definitely restricted. So what happens here is for the y value, you need to realize that this graph, this vertex, is right here on the y-axis. And that's the lowest possible point that the graph is going to hit. So what happens is our vertex happens to be at -2, -4, but we're just dealing with the y coordinate of the vertex. It's all about the y's. So what happens is our y's are going to be greater than or equal to that -4 because that's the lowest y value that we see on the graph. Let's see if that's going to work when we go to this next one. Domain. No matter what, domain is always going to be x equals the real numbers. It's just always the answer. The range, well, we got to figure out what the vertex is. So the vertex right here is going to be over 2, up 3. We're dealing with the range. We're dealing with the y values, okay? And in this case, this y value happens to be the highest point, right? So no graph, no part of the graph goes above that particular point. So we've got y being the highest point, or every other y value is less than or equal to 3. Make sure that makes sense. If you have minimum values, your y is always going to be more than or equal to the y coordinate of the vertex. If your vertex is a maximum value, your range, your y is going to be less than or equal to the y coordinate of the vertex. I'm going to go back to this slide for 1 second. So the set of all of x values always, why is it not working for me? Oops, hold on. What's happening here? So it's always going to be, let's try this again, the domain, here we go, is going to be x equals real numbers. And that's always. Okay? The range depends on your max or min. So the range depends on vertex. So if max, your range then is going to be, your range is going to end up being y is less than or equal to y coordinate of vertex. And then if your vertex is a min, the range is going to be y is more than or equal to y coordinate of vertex. So hopefully that is going to be helpful to you. So this should then be enough to get you through to the homework, okay? And that's it.